Okay, guys, the homework that's due April 23rd, I think, Friday, April 23rd. Cavalieri's principle. I think it's pretty straightforward for most of you. Cavalieri's principle basically says if you have the same base area and the same height, you're going to have the same volume. So it tells us in this problem, all of them have the same base areas and all of them have the same height. Now, visually, you should be able to clearly see which two of these can have the same volume. I mean, this shouldn't be shocking to you. These two, because they're conical, well, this is a pyramid and this is a cone, but that's the reason those two, they have the same base area and the same height. So they're going to have the same volume. Okay, consider the following rectangle-based and triangle-based prisms. Okay, we've got a triangle, a rectangular prism, and a triangular prism. Luke tried to use Cavalieri's principle to show that the two figures have the same volume. The base areas are the same, therefore corresponding cross-sections have the same area. The prisms have the same height, so the volumes will be the same. What was the first mistake Luke made? Well, let's see. The biggest thing here is, okay, they definitely have the same base area. The area of that triangle is 6 times 4, which is 24, but because it's a triangle, you cut it in half, that's 12. 6 times 2 is also 12, so they definitely have the same base area. Where his mistake is they don't have the same height. This has a height of 10. Now this has what we call a slant height of 10, but its height is 9. So it isn't true that the heights are the same. Okay, considering the following cylinder and cone. Okay, Marcella tried to use Cavalieri's principle to show that the two figures have the same volume. The base areas are the same. Well, that's true. They both have the same circle. Therefore, corresponding cross sections have the same area, so the volumes must be the same. Well, again, where's the problem? Well, clearly you can tell they don't have the volume the same. They can't. Well, the reason is the cross sections. If you chop right across here, yeah, the bases are the same. But if you chop right across here, the circle you get here is much smaller than the circle you get here. So it isn't true that the corresponding cross sections are the same. Last one, considering the following prisms. Again, we have a rectangular prism and we have another rectangular prism, but this one's called oblique. It's kicked over, it's not right. Those bases are both squares. Okay, so it says, Naomi tried to use Cavalieri's principle to show that the two figures have the same volume. The base areas are the same, therefore corresponding cross-sections have the same area, so the volumes must be the same. Well, clearly the bases are both a square that's 8 by 8. The next question is their height the same? And their height is indeed the same. This is different than the one that was the mistake before, because here the height is 12, here the height is 12. We don't care about what this slant height is. They have the same base area, they have the same height. They do indeed have the same area. Now, where did she make a mistake? The base area is the same. Well, the only thing okay, I'm actually confused by what they're asking here. Oh, she just didn't say that they had the same height. That's all. So it is true that they have the same volume. She just never said it. That one is a little confusing for me. But yeah, these definitely have the same volume. She just didn't say that they have the same height. So she should have said that in her answer. All right, again, perfectly understand. That's why I leave my mistakes in. I want you to see that mistakes are made. I made a mistake. You can make a mistake. Just go back, make sure you understand what you did wrong. Ask questions if you don't understand something. Have a great weekend.